Okay, welcome back. We are continuing with our chapter 6 discussion, and we are talking about calorimetry and energy flow. Today I'm going to discuss enthalpy and introduce the concept of, and so we're going to be moving away from this delta E, this changing of energy, into enthalpy, which is more of a chemistry term of the flow of energy, but more specifically heat. Okay, so enthalpy is given as, is defined as the sum of the delta E value, the change in energy of the system, plus P plus delta V. Now remember that this is basically work, because work is equal to negative P delta V. And so this is really the change in energy minus work in order to get that sign correct. But it turns out in chemistry terms that there's usually not a lot of work that happens. So remember that work is a change in volume. So blowing up a balloon, work is being done because the balloon is going from a small volume to a large volume. But if you think about the reactions that we've done in the lab, the volume of those reactions doesn't really change. Otherwise, whenever we're titrating, we would have to keep getting a larger and larger beaker, or we would have to get our size of our solution would be shrinking as that reaction happens. And we don't really see that. And so for chemistry terms, we can make the approximation that work is approximately equal to 0. And this is a pretty good approximation. And so when we make this approximation, we can define enthalpy to be equal to the change of energy of the system. And like I said, this is usually a good approximation because the volumes of the amount of work done by chemical reactants tend to be really small. In other words, volumes stay fairly constant during a reaction. Okay, so sign conventions for enthalpy. For a reaction to, there's two conditions. Condition 1 is defined as an endothermic reaction. And in this case, for the reaction to occur, energy must be added to the system from the surroundings. And so the energy flow is going in this direction. It's going from the surroundings to the system. Or another way of representing that is that our reactants are at a lower energy and our system gains energy to move to the products. And so energy flows going from the surroundings to the system, or our products have more energy than our reactants. Endothermic reactions, delta H is positive. The opposite of this is an exothermic reaction, and this is when energy is moving from the system to the surroundings, so the energy flow is going towards the surroundings, or energy is being given off from the reaction. And this happens when the products have more energy than the reactants. And so the delta H is negative. So exothermic reactions, delta H is negative. Okay, so to summarize, the value of delta H for a chemical reaction is the heat absorbed or evolved when the reaction under the conditions of constant pressure. And so remember that work equals negative P delta V. And so that means that our pressure cannot change. And so in our enthalpy, the pressure cannot change. So we are always working at constant pressure. Now, the good news is that most of the time we do our reactions sitting on the lab bench, which means that the pressure is always going to be the same. An endothermic reaction has a positive delta H. It absorbs heat from the surroundings, and we can sense this as it feels cool. And so this is something that whenever you hold it, it gets cold. A cold pack. So if you've ever used the ice packs where they're a chemical reaction and you break them apart and you shake them up and then they get cold and you put them on your sore muscles or your achy joints, this is an endothermic reaction that is happening. An exothermic reaction has a negative delta H and it gives off heat. And so it feels hot to the touch. And so this is a hand warmer. So when you go skiing, you break open the little pack, you shake it up, and it gets warm. That there's a reaction happening inside of that pack, and that reaction is exothermic. Okay, so from here on out, we're going to really be talking about this enthalpy term and how to measure it and how it relates to Q. So in the next couple of videos, we're going to start working through some of the calculations having to do with enthalpy.